Welcome back. This is Percona's little bi-weekly Postgres talk. Uh, we're part of this is the Percona Community Postgres live stream, the official title. My name is Dave Stokes. I'm a technology evangelist, and with me is Charlie Batista. And today we're talking about how to secure Postgres. Um, in the old days, it was very, very simple because you just shut off access to the card reader and no one can get to your database. That shows how old I am. So, Charlie, what do we need to know to lock down our Postgres server?
Hey David, nice to be here again. So on our bi-weekly, that used to be pretty simple, right? So
Yeah.
just cut up the cables. And, yeah, you are secure, no problem. So yeah, but things have evolved since then. Uh, People have found more and more ways to try to steal your data, not only steal your data, but compromise your service. And security, it's becoming a complicated, complex beast, I would say, nowadays.
Well, I actually had someone ask me last week or the week before about is SQL injection still around? Is that still a problem?
It
And
is.
it's
It
like,
still happens.
yeah.
Funny enough, it still happens. And that's the thing. When we talk about security, it's a huge topic. It's something really huge. And but the things that always comes to our mind, the first is access to the database, right? So when I talk, okay, let's talk about secure the database, secure Postgres. We want to prevent unintentional access to the database. Someone that doesn't have privileged access to the database, but it goes a lot beyond those things. And we see nowadays there are very sophisticated attacks. The SQL injection is not new and it's not so sophisticated anymore, but it's used to be a sophisticated one when it came to, right? Especially when language like PHP back that time, ASP from Microsoft, ASP, they were popular languages. Those things were really trendy, like SQL injections, and those things are really popular. They're not so popular anymore because most of the languages today they have frameworks that help you to build applications, and those frameworks they already work on something. They have some measures to prevent those, but they still happen. They still happen.
Mhm. Well, as long as humans are involved, we're going to do something creative or destructive unintentionally or intentionally that will mean some poor person has to do a backup, restore, and explain.
Well, one thing that I've seen recently, not well, in the last few years, that it's been increasing, are people hijacking the whole data store, right? So I now I forgot the name. They for those surgeons they encrypt your whole data store, your disk or OS or something, and then they charge you some money to give you the encryption key, right?
Well,
And
it's kind of funny. 4 years ago, when MySQL 8.0 came out, by default, SSL was turned on. And a lot of folks are saying, well, that's overhead. That's going to slow down my server. We don't want, that sort of overhead. And then we start pointing out that, you really don't want a man in the middle sniffing your credit card numbers and everything else and ruining your PCI compliance. And after a while, the overhead doesn't really bother us much anymore. How do we make this more secure?
that's the thing. And and that's the thing. So when it comes to secure the database, you have different levels that you need to go, right? So for example, the one that you're talking about, the network security level, right? So it's very important. Sometimes you have really a strong authentication system, right? So your authentication system enforces your user to have a password with 100 characters, with numbers and characters and letters, and everything is so really sophisticated. It's check against the dictionary, those a lot of things. And but then everything goes on text, clean text on the network, right? So you failed miserably on the security on that aspect, right? So one that does this thing gonna fail miserably because it doesn't matter how complex is your password. If it's easy to get that complex password, people are still gonna get that, right? So that's the thing. When it comes to security, we have many different layers. So we have the network layer. We have the database level security itself, like as we explained. So you don't want to expose your database, right? In all times, as you mentioned, so you could just cut the wire and then your database is secure. Nowadays, that we are going through the the internet, we don't want to expose the database like through the internet. I've seen a lot of security breaches for other databases that the team went installed the database, the port was open for everybody, and the database didn't have a password. It seems naive, but it still happens. Like if we go there, most of the security breaches on the database world are because of those things. Because of, and the first thing that we need to do when we're talking about security is to have a checklist, right? Okay, this is my checklist. And go first for the easy and stupid mistakes. Because, well, if you fail on the stupid stuff, it doesn't matter how hard your password is. It doesn't matter how complicated is the algorithm for your SSL or your TSL. If you still expose your database with open port, with no user password, so it will be pretty easy, right? So, and those are the things that I've seen happening. But beyond those things, okay, what should we be concerned about when we are securing the database? Well, first thing is access, right? So the first thing we need to be concerned is about the access. You should make your database as hidden as possible, right? Your database should not be exposed to the whole internet, for example. Your application should be exposed to the internet, not your database, right? So if you install your database, it's a very good practice to have network isolation. So you install your database in a private network, and then your application has access to the internet. So you can access your application, not the database. That's the first one. That makes things a bit harder to an attacker to access your database. So another thing that you should do is secure the communication to your database. One may say, oh no, but like it's on my private network, right? So what is the problem? Why do I need to use a TLS or SSL connection to my database? As you mentioned, so yeah, it makes my database slower, right? So I'm gonna have latency on my database. You're gonna use more CPU, and so, well, we never know who is working on our side, right? Maybe the guy that was just next to you wants to get some private information that he's not supposed to have, right?
Well, I know from the MySQL world, we always said, make sure you put your application to database traffic on its own network, your replication traffic on its own network, because there's nothing like having an LDAP update and a DNS zone change on the one pipeline fits all party line.
Exactly. And well, yeah, and there are even those problems, right? And when you start building that segmentation, so if you start segmenting your network, connecting to the database, it's a lot easier for you to improve security. It's a lot easier for you to troubleshoot performance problems, right? Let's, for example, if you have a replica that's lagging from the primary, well, what is the problem? The problem might be that your network has been flooded by the application. And maybe your replica is working pretty well, your primary is working pretty well, but then you have a bottleneck on the network side. If you do not have any segmentation, that's going to be complicated to troubleshoot and complicated to fix. How are we going to fix such a problems, right? So having this segmentation on the network is very important, and it's important for security, important for performance, important for troubleshooting, for many different angles and perspectives, right? Those are the things that we need to be concerned. So if you enforce the access, it makes it more complicated. An attacker gonna already have a problem. So another thing that you, on the access point of view, you need to enforce are the authentication. And here there is one point. People usually confuse authentication and authorization, right? On the authentication, you grant someone access to something. Well, actually, you don't grant. You check if that person is who he or she is saying they are, right? So, okay, look, I'm Charlie. Here is my ID. You can see. So this is my ID, my photo. So I'm Charlie. But yeah, I'm authenticating that you are Charlie. Then comes the authorization part of the process. Well, nice, you are Charlie, but I don't care. You have no access here, right? So those are different things, and they're important because when you make sure that your authentication process is strong enough, so that's going to be harder for someone to fake information or to impersonate you. Look, see, I'm Dave. Look, nice. I even have this nice bird here. See, I'm Dave, man.
Well, that's how the computer recognizes actually by facial fuzz. Yeah.
It does. It is. Yeah. So, and but like, okay, let's say I can fake, but if my user, if that user it has really restricted access, or the only access that it's needed, that's it would be not a smaller problem, but the problem might be less problematic, right? Because another thing that I've seen over the years is, okay, we have this huge database. We have a few terabytes of data here, and we have 10 applications. All the 10 applications use the very same user. Even when they don't need, even if the application A has one schema, application B has another schema, they do not share any information about them both. They're completely isolated. And the only thing they share is the resource, the same database. So yeah, the same instance they have on the same, that's the resource sharing. That's okay, that's fine. And they have the same user. And the user has super privileges.
I used to recommend that people have a separate account for reading and writing, and different reading and writing accounts for each project. And someone said, well, why do you do that? I said, well, the situation for your application is you have a lot of programmers who open up a port, do 5 or 6 different queries, sleep for a while, do some computations, come back. And your problem is you don't have any sort of port concentration going on. So, you know, the quicker they're in and out, the better you are for MySQL. Postgres, you have the opposite problem where every time you come in, you have to fork off a process, get a user running, and then attach it. Is that a big an issue for security? Do people try to circumvent that problem?
Well, that depends on in the end of the day, all the process they run with the same user, right? So if you create one or many process, they're gonna run on the OS perspective. They're gonna have the same user that is running the Postgres. Mm-hmm. So the user on the database side, they are not really related to the user on the OS side. So on this at this end, it's fine. So I don't see really a problem. But then you should the user that runs your database, you should have the very specific, the only privilege that's really needed to use to run the database. The folders, they need to be with proper access only to that user. So, and on this sense, Postgres does a pre-check. I think most of the database, they do a pre-check on the folder. If the folder has access like 777, so it won't run. But it's really weak check. It's really weak check. We need to put more constraints when we are creating the user and grant the OS user that runs the database. Again, we don't want to have a super user, a user that has sudo privileges on our Linux box to run the database. It's not needed, right? So we need to have the proper ACLs to go there, to use the proper EC Linux, everything. So we don't disable the EC Linux, right? Because the database runs entirely on the user space. There is nothing much that Postgres needs that is outside of user space. So it really doesn't need to have root privilege to do anything on Postgres, right? That's one thing, right? And then when it creates a new process, all those processes they're gonna be spawned. We're using the same user. Let's say we're using the user Postgres. They're gonna have the same user as the main process, right? It's just a copy of a new process. It's a child process. In that sense, if we secure enough the user that is running Postgres, that's okay. Like it's the kernel does a really good job to preventing those privileges to be leaked out of the user space. That's I think from security point of view, using either thread or process in this sense, I think at most is the same. The problem comes when inside of the database itself. When you create the user on the database, let's say we have two different applications. We have one application for sales and another application, I don't know, for finance, right? So the finance one is the application that you organize all the paychecks, you organize the salaries and everything. So what prevents you, a user that has the password, the access from the sales application to go on the finance and increase his own salary?
No one would ever do that.
Wow, yeah. And this is it's a stupid example, yeah, but if you have one user for all the applications, a bug, or if you have an attacker, someone that gets access to your application, that to your point of sale application, gonna have access to all the other applications, right? And even your finance application. So it's really critical to also have this separation of application of user when you have multiple users, even or multiple applications on the same database. So it's a lot better to create a specific user for each specific application and grant only what those application needs, only those tables. And one thing that is really nice when it comes to Postgres is because the granularity of what we can do on Postgres is it's impressive. We can go for row access, right? We can control at row level, like to tell which row that user might be able to access or not. It's really huge granularity, right? And if we go to the documentation, for example, let me share my screen. Where is the screen share thing here?
Well, while you're sharing that, do you recommend having different schemas for each application? One for finance, one for dev, one for admin?
Yeah, I do. Actually, I depends on how you organize your application. I would even recommend to have different databases on the same instance, right? Because if you do not share any information across applications, you can have different databases. So you're able to see my screen here.
There we go.
Okay, let me try to increase here, make it better. I think it's easier to read now, right?
Yes.
Okay, so this is the role security on Postgres. So as I was mentioning, we can, for example, create a policy that we, in this example here, the manager gonna, when he do a select on the table account, he gonna see only the roles that the manager column here inside of the roles is equal his username. So he won't be able to select any roles that's not managed by himself, right? So, and he won't be even in this case here, even able to insert or delete roles that doesn't belong to him. If he wants to insert anything on this table account, the manager needs to be equal to his user login. So when it comes to secure the database, on the access to the database, the granularity that's given by Postgres is really amazing if we think about that, right? Because we can really go to the role level secured on Postgres. It's not only, okay, the user Charlie doesn't have access to the table accounts. That's fine. Every database that can do that granularity. On Postgres, you can tell, okay, yeah, the user Charlie can access this table accounts, but he can only see or only manipulate or only access the roles here that belongs to him. If the manager is not the user Charlie, he cannot see, select in this case, he cannot update, he cannot delete, or he cannot even insert any role here and record here that doesn't will not belong to the user Charlie, right? So this is the level of granularity that we can get on Postgres, and we should start taking advantage of those things when we go to the database. Back to your question. So one thing that I used to decide if I gonna create a database or a schema is if the information is shared. On the example that I gave about the point of sales system and the finance system. Well, we might have some information that been shared among those two systems, right? So, like for example, the stock, the amount of products that we have in the stock, we might need to know them for the point of sale because we don't want to sell something that we don't have in stock. And the finance might need, or other department might need that information because, well, they want to buy more of those things that you sell the most, right? So because we're sharing information, in this case, the best approach is to use schemas inside of the same database, right? We have one database, and then we have one schema for the finance, another schema for the point of sales, and we might have a common schema with those shared information, right? So it's a good design that you can have different. We can have this segmentation by schemas, right? If the systems they're totally independent, I usually recommend to have independent databases. If you do not share anything, if you never share anything, so then we have one database on the same instance for the finance, another database in the same instance for the point of sale, right? So in this way, it's even easier to make the segmentation of the user. The user for the finance, he won't be even granted if access to the other database, right? It's a lot easier to do those things. For the other hand, Postgres doesn't support cross-database select. So if you need information, let's say you connect to the database point of sale, and you need to get an information for the database finance, you need to disconnect for the database point of sales, connect to the database finance, and do that select. It's not like MySQL that you can do a cross database. You put the database name, the table name, and then you do a select. It doesn't work on Postgres.
Okay.
And that's the main reason why we recommend using schemas when you need to share information, because this cross select doesn't work on Postgres. Right? So, and yeah, as I was mentioning here, so when it comes to the database access, there are a lot of granularity that you can specify, you can go deeper and deeper on Postgres. So not only, okay, I'm not going to grant you the access for this table. No, yeah. Look, Dave, I'm gonna grant you access for this table, but only for the specific roles where you are the owner. Let's put it right. You are the owner. You are related. Whatever. We can use the policy. We can make the policy very complex, right? Uh, and those are really nice features that we have on Postgres, that we start enforcing the access. In this example, if the user Charlie here leaks the password, if someone gets my username and password and access the database, he will be very limited to the number of actions that he can do on the database, because my user on the database has a lot more limitations than a super user, for example, right? So those are part of the process of enforcing, right? On the checklist, okay, what users we need? Yeah, we need 10 users. Okay, what access those users really need? Do they need to access the whole database? Do they need to access only one schema or two schemas? On that schemas, do they need to access all the tables in that schema? So if we start doing that segmentation, even in the case when we have a security breach, and the thing is not if you have a security breach, but when you have a security breach, right? Because it's proven that we will eventually gonna have a security breach. Most of the major companies, they all had, and they're probably gonna have again. So, and the thing here is that we're trying to do is minimize the impact when we have that security breach, right? And this is, and you can go over and more things when talking about securing the database by the access control. So there are a lot of things that we can do with the data access control, grants and things. And but moving on, so far what we did on our checklist. Okay, we secure our database on the segmented network, right? We don't have our database exposed to the world. The ports are blocked. The user needs authentication. Another important thing here that I forgot is Postgres, just like other databases, when you go to authentication, you can grant access to the user without password, right? So when you go to, there is this file PGHPA that you can do a configuration to tell the database that user is a trusty user. You trust that user, and you can tell, okay, I trust this user if it connects from this IP or this box, so this database, right? You can tell the post, right? I trust this user, and the database will not require any password. I've seen a lot of database with this configuration for the user Postgres connecting on the local host using, well, why this makes things easier when you are troubleshooting and access something, you just go, you do an SSH, su-postgres, and then from then you do a PSQL. It doesn't ask you password. It's a huge security breach. Because sometimes a person just grant access to your box, but it's not granted access to the database. So if the person already has access, like if you do not have any user and password to the database, then the person already has access to everything. But one can say, well, it's easy to just go change the HBA5 and do a database reload. Well, that's true, but we can have monitoring on the database reload states, and you can have an alert if that very specific parameter has changed, right? So you can know in advance, so you can know a lot faster if someone is trying to grant access to your database. And for the other hand, if it's already there, the person just connect to your database and do whatever he or she wants to do, right?
Okay.
So it's never a good idea to leave users without password on the database. It doesn't matter if it's the connection is local connection, it's connection from outside world. It's never a good idea to leave a user without password on the database, right? And it goes to the very first check that we have on our checklist, right? It's it's always good to reinforce that always give your users a password, a good one, right? And if you go about the passwords, there's long discussions on, okay, what type of password should you use? Should you use a checksum like MD5 or Scram or whatever other checksum? Should we use another type of encryption to get the database, the passwords encrypted? Should we save the passwords as plain text on the database? How should we work? Right? So I would say that leave it as in plain text is never a good idea. Right? You have your username and all the passwords there as a plain text. Well, it's never a good idea, right? So most of the recommendations are to use at least one checksum, like not MD5 anymore. MD5 is proven to be pretty weak. But there are other SHA-256 or Scram SHA-256. There are many others that are a lot better than MD5. So do at least that one. The problem about having those checksum algorithm is because you cannot decrypt back. Right? So if the user loses its password, you cannot. There's no way that you can get the password back. So you should have a solution to let the user to change the password. Right? Some sort of proven authentication, proven that who you are and change the password. Another solution would be to use a full encryption algorithm, for example, with using asynchronous keys, right? So, but then you need to make sure that you have the key secure. A lot of people, I've seen applications that they use this type of encryption. So, but then they store the private and the public key inside of the same database. It's the same as you store in plain text, right?
Yeah.
So if you have the private and public key inside of the database to decrypt it's the same as have a plain text. I've also seen some applications that they do a bit more complex. Let's say they put the public key on the database, and the private key they put on an application file. The configuration application, the configuration file on the application side. It's still in plain text. It's still there. So if you have a security breach and someone is granted access to your application, so in the application configuration file you have the user and the password to access your database. You have the key to decrypt all the passwords inside of your database. What else you need, right? So it's granted there for free. You just need access to the application. And those are the things that you need to be careful. We're going to use encryption. So let's use a vault or some sort of solution that make things a lot more complicated, right? For an attacker to get those things. And you see, a lot of those things that are outside of the database world itself. They're not inside of the database anymore. And this is when things get complex and complicated because you need a diverse team to help you to 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 build, to configure those things inside of the database.
I know at-rest encryption is a big subject for a lot of folks.
It is.
What are our options in the Postgres world for that?
Well, Postgres doesn't have it native. What we I seen a couple of plugins working on this. One thing that it's I've seen a lot of people doing. It's not really at-rest encryption. Is to have the file system encrypted, right? So it's not on the database. The file system encrypted, and you run solve a lot of problems, right? So if you have an attack, on file system attack, and someone gets your file system or whatever, and they copy, so your file system is encrypted. When it comes to encryption and database, there are a lot of different challenges. The first challenge is on the data access on search, right? So if you, let's say, if you have at-rest encryption on the database and the database really encrypt the table files. When you do a select, for example, you need to decrypt the index before you put it in memory, right? So, and then the problem about that is you need probably to decrypt the whole file because, well, you need to, on a naive implementation, you need to decrypt the whole file, and then you go to find the role you are searching for. The search, it becomes a lot slower, and then now you have a lot more CPU and memory usage than if you're not having. So it's a lot more complex to build at-rest solutions when you have encryption inside of and done by the database itself. So it's a lot faster and easier to have it done by the file system itself, right? Because, okay, on the database layer, you have where you know where the data file. So you get that those blocks decrypted. You just ask for the file system. Look, I need the blocks 1, 2, 3, and 5, and then the file system gonna get and give it a block. But answering your questions, I don't know of any really good implementation of full at-rest encryption for Postgres. I know some implementations that they do part of the solutions, and then you need to mix that. For example, having the file system encryption is the most common on Postgres world. Is the most common one that you encrypt the whole file system. And everything else that you need to do, you need to go for plugins or for extensions. And the ones that support more features are not open source on Postgres for at-rest encryption. And that would be really nice to if anybody on the audience have been working or know about and anyone on Postgres and some a new project, and if they could share, I really would like to take a look and see how the progress is being doing on that front. But from what I've been working, there are no much progress on Postgres world on this. I've seen a lot of discussions from people that need and people that want, but real progress I haven't seen much on the community.
One thing I learned the hard way many years ago, there was a company that had a new accounting clerk, and they figured, well, we'll just take the head of accounting's account, clone that over, and give it to this novice. Well, the novice wasn't really good with SQL and didn't do a where clause on a delete statement. And it was like, why did we give a novice delete privilege? Oh, we just had a question from XYZA. So reading from memory doesn't have encryption. I know of very few systems that actually encrypt things all the way through into memory and then just keep it encrypted there. Have you run into anything like that, Charlie?
Well, that's a really good point. In the end of the day, when you're gonna on your application, it's either the final application on the database works with the data in memory. The data gonna be decrypted, right? The in-memory data, the final operation with that data gonna be decrypted. It cannot be encrypted because you need to get the data. That's a huge argument, for example, for passwords. If you have the best secure encryption system and a huge password and everything, when it goes to memory, it's gonna be decrypted in memory. So the everything that goes to memory at some point, it will be decrypted, right? So you get the data will be there. You have a memory. If you do a memory dump of the application, you can from that memory dump you can get access to the key. You can get access to the encrypted and to the decrypted data is in there because there is no other way to work directly with the encrypted data. Or at least now, not yet. Maybe we improve and in the futures we solve those things out. But at now, when we really work with the data, yeah, it's decrypted. In memory, it will be eventually be decrypted there.
So thank you for that question, XYZA.
Yeah, that's a really good, interesting one.
So what else can we do to keep the Joe average snooper from getting into our database?
Yeah, so we've enforced the access, right? We enforced the authentication, the data access control. We've been enforcing that as well with all the roles and grants that we did. Encryption, we've been enforcing encryption from the network perspective, right? We are using certificate, TLS, SSL, and everything all related to the connection. So our data gonna go secure to the network. So those two endpoints, they've been using encryption, right? So we also been applying the encryption for our data layer, more or less. And in Postgres, as I mentioned, the most common one is to encrypt the file system, and there are many solutions in the market, open source ones. And so now, another thing that we can definitely do is to check and start granting different privileges for the topology on the network for the host, right? So not all boxes in your network need to be granted access to the database. So even when you are in a private network, you probably only need to grant access to the database for the application. Obviously, the application needs to have access from a couple of boxes of your DBAs and everything. And everybody else, probably none of them need access to the database, right? So if you prevent them, and in Postgres it's pretty easy. We don't need to use complex firewalls, rules, and everything because well, we are inside of our own network. You can go to the configuration file on Postgres and grant access to those very few boxes, very few machines, can be IPs, names, or whatever you use to access your database, right? So that person, if a person wants to breach in your database, it's another thing that the person needs to figure out, right? We have a question. So column level encryption with only update and set access is best policy? I'm not sure that I fully understood the question. Well, what I understood the question is asking if a column uh, level, oh, column level encryption with only update and insert access. I understood something else when I read the question. Now I'm even more confused.
Yeah. Can you give us a little more clarification there? I know
Because
some secure systems you can insert all the records you want, but every update's going to be an additional record, and there's no such thing as a delete until someone with a master policy grant can come through and get rid of it. Kind of like a primitive version of blockchain where everything's append only until someone with very, very high privileges comes through and calls out the old data.
well, I'm not even sure if that would be possible for you to only encrypt the data. Well, because it doesn't make sense to only encrypt the data during insert and updates, right? There are two main problems for data security, data breach. One is the access of the data itself. For example, if you have your credit card number on the database, you don't want anybody to access that information, right? So it's accessing the information, it's a problem, it's a security breach. So when we use those policies to enforce or to make things hard and difficult for somebody to access is because, well, accessing the information itself is already a problem, right? That's one thing. Another thing is manipulating the data, right? So we don't want anybody else to manipulate and faking the data. The example that I gave, the lame example of changing someone's salary, right? So I could grant access to the database or a banking system. I could grant access to a bank database and then send the $10,000 from Dave's account to my account. So we don't want those types of things to happen, right? So we don't want anybody else, anybody that has access to the information to see the data. It's a problem. And we don't want people changing the data. So let's say it's possible to only give encrypt the data when it's inserted. So if we only encrypt the data when it's inserted or updated, what happens if we need to access that data? That data needs to be decrypted, right? So the point is when we read the data, you get in memory, but that makes sense. We really only encrypt the data when we write. That's when we encrypt the data, because when we read, you just discard the data. If you don't need to update it to insert the data, you just discard the data. You don't do anything with that data. So yes, when you do encryption, you only encrypt the data back to the file system, to the data file, when you're writing back the data. But you still need to decrypt that data when you read that file. So we read that data, you put back in memory. When it comes to memory, it still needs to be decrypted. Even if it's for a delete, we need to find where is the role, the record, and you still change that block, because even though a deletion on Postgres or any, like most of the database, they are not physical deletion, you don't remove, you just mark. That logical deletion is still changing that block. You still have one bit at least to change that bit from valid to invalid, right? You still need to, and after you change that block, you need to recalculate the encryption to write it back to the disk, right? So every time we do manipulate the data, it's either insertion, update, or deletion. We need always to encrypt the data back. And when you're only reading the data from the disk, we need to decrypt and put it back in memory, right?
At what level can we control encryption? Can it be done at the table level or table space level or schema level?
So this is the at-rest encryption that we are discussing before, right? On Postgres, natively cannot. Postgres doesn't by itself that doesn't have at-rest encryption. So the easiest way that we do encryption on Postgres today is encrypting the file system. So that means it cannot be done at this level of control. You cannot just encrypt a table space or a table. Well, you can do a table space because you can have table spaces in different file systems. In this case, you can, because it's on file system level, you can have table space A on one file system and table space B in a different file system. So you can control on the table space basis because of that. But it cannot be done on a schema basis on our table base level because it's file system level encryption. It's not database level. There are plugins on the market that can do those, but they are not the ones that I know. They are not open source, right? So that's something. The ones that can do for Postgres on, then it's at rest encryption. It's inside of the database itself. It can do at table level. It can do at row level. Actually, not only table level. Some plugins that can do at row level, but they are not open source.
Cool.
And it's a really nice open source project. So someone out there that wants to have a good idea, okay, what project open source I want to do for Postgres, encryption is a really nice one.
Yeah, and you can use an existing Vault manager like something from HashiCorp or something similar.
Exactly.
So the major hard part, the encryption key management and rotation part is already taken care of for you.
It's already taken, exactly. And we can use like examples like or we can base our solutions in some solutions in the market with other database. For example, the Percona server for MySQL, we have at rest solution there, right? So we can borrow some ideas for those other projects and start one for Postgres. Why not?
Very cool. And I want to thank you all for the questions. So far, we've had a couple from XYZA, and I'm going to butcher this, unfortunately. Amitabh Sarangi. Cool. Now, something else to secure your database, backups.
Backups.
If you've never walked in to find out that one of your servers has rusted out a bearing from a leaky toilet 2 floors up on a Monday morning, when you work in a university, I can guarantee you it is quite a thrill. Someone put a explosive device in a urinal in a men's bathroom, and the water leaked down and took out a mini computer used by a lot of the students. And it's one of those things where, very luckily, Friday afternoon, backups have been made. So, what do you recommend on backups?
Well, backup is a huge topic, right? So my recommendation is to use a tool like GBackrest for backups. And the same thing, you can have a specific role to do the backups, a specific user to do the backups on the database, right? Gonna be specific privileges. You don't need to grant everything to that user. A tool like PGBackrest, you can do everything. You can do full backups, you can do incremental backups, you can do differential backups. Right? You can have a backup. You can parallelize your backup. Right? You can use more than one thread to do backup, and you can comprise the backup. So a lot of things can be done using a tool like PGBackrest. On Postgres 15, the PG-based backup tool will be able to compress the backups when we're doing so. Things like that was being done for a long time for tools like PG-based backup environment and other tools that we have in the market. Right? So my suggestion is use a tool to make your life easier. You don't have to do it manually. We had a stream here with Matt when we went through the backups and we showed the manual process. It's not complicated per se, but it has many steps that, well, it's easy to confuse those steps and make a mistake. And then you have files, but you may or may not be able to recover a database using those files, right? So no one want to have files, and when the water leak under your small computer happens, you're not able to recover the backup of the database, right? So it's not what we want. Then the suggestion, yes, use it too. The one we recommend at Percona, and it's in the market for a long time, is PG-based backup. PG backrest, sorry. That's what the one we recommend at Percona. But there are others, there are PG Barman and or a couple of other tools there that if you use it too, if you have knowledge on them, they are good tools. Right? They get the work done. That would be my recommendation for things.
We have another question about, can you use LSM trees?
Postgres, when it comes to, I suppose the question is about indexes, right? And when it comes to indexes in Postgres, the answer is yes. Indexes in Postgres, they are quite extensible. We can build our own implementation of index that we want, including LSM trees, V trees, and any different types of trees. If the question is related to the file systems, some file systems, they do use LSM trees to store the inodes and things. Yes, it's also possible. So as long as the interface, the API to the file system returns what's asked, yeah, it's definitely possible to use LSM trees in Postgres.
Yeah. I even found out someone's working on RocksDB for Postgres, which I find impressive.
It is, and that's another thing. Like, even though it's not so popular out there to have other implementations of data store for Postgres like MySQL. Like on MySQL, we have MyExam, we have InnoDB, we have MyRocks. So it's also possible to have those implementations for Postgres. Right? So Postgres has its own API that interface the engine, right? We can have it, not like it seems it's easy to believe or think that we cannot extend or change the store engine on Postgres database, but actually that's not true. It's possible. And there are some other implementations, as you mentioned, some people implementing a change like MyRocks for Postgres, right? Yeah. And on the index side, it's really extensible. For example, the PostGIS, they built a new whole ecosystem that works inside of Postgres, and it's just an extension. Nothing changed from the core, right? So you have new types, you have indexes, you have many other things that's built just to accommodate that PostGIS ecosystem inside of Postgres. It's impressive how extensible the database is.
Yeah. And another question from X was the actual statement: backup encryption in the bank industry is very important for audits. In something we use backrest to take encryption backup directly to cloud storage. And that's a good thing to know. To perform this, we use account impersonate privilege. That's something else for me to go out and look at. So
yeah, that's true. As I mentioned, tools like PG backrest is a really good tool. You have a lot of options, and including you store the backup encrypted already in the storage subsystem.
Very cool. So we have managed to kill off pretty much a good hour on this, and we've kind of just barely scratched the surface. And I probably screwed up your entire canned presentation that I know you probably have. And with that, I want to thank our folks who asked questions, especially a big shout out to Charlie. Just found out Charlie will not be going to Berlin for Postgres Europe. So you folks are going to have to do without him. We have other folks going who are almost as impressive as Charlie. And if you do have questions or comments or have something that you want to see extensively covered in one of these things, please let us know. And with that, I want to sincerely thank Charlie for his effort and his knowledge. I am still very much a novice in the Postgres area, and these things are always very enlightening for me. And when I'm doing these talks, you mentioned something, I'm over here on my other screen going, what the heck is that? So this is always a great show for me. So thank you, Charlie. Any last comments or recommendations?
Yeah, thanks for the nice words, for the compliments. People going to Berlin, we have a lot of knowledge, folks from Percona, some of them a lot more knowledge than I am, and this year I won't be able to attend there. So the Europe, I have some personal activities here that I need to clean up. But that's we always invite people, the community and folks and friends to attend the events, right? It's always good to see in person, to talk, to have great discussions, and to make the community stronger and stronger. This is one way that we have to improve and enlarge in the Postgres community. And thanks again for this nice talk. It's always good. It's always great to be here and talk to you guys. It's a pleasure.
Oh, here we have anything on moving from Exadata to Postgres. I don't know anything exactly about that. I could see why you want to do that for financial reasons. Call our consulting folks. They probably have other customers doing that. And can we cover performance tuning? Well, that might be an entire series of talks that we do coming up in the future. And with that, I want to thank everyone for participating and for the folks who watch the stream after it's done recording. And thanks again. And if you have questions, go to percona.com and let us know. Take care, folks. Bye, Charlie.
Bye.